Good morning, friends. In our previous lecture, we complete our chapter number second. Today, we'll see chapter number third: limits, fits, tolerance, and gauges. This chapter is for 12 marks, and in that chapter, we have to see what are the different types of limits, then types of fits, types of tolerances, and types of gauges. Before going to start, there is one important concept called as interchangeability. Interchangeability is nothing but it is an ability to interchange various parts during assembly, called as interchangeability. Uh, it happens uh, in old days some same worker are used for production as well as for assembly. So separate inspections were not required to be carried out at the time of manufacturing. That means same worker, as if there is a problem during assembly, so same worker can solve it. But in modern technology, so different technologies are due to globalization, different new technologies are generated, and hence different machineries are used. So new concepts are launched. That's why nowadays all parts of an assembly are manufactured at different places and assembled at different places. So to cope up with demand of mass production, nowadays production should be such that it should be assembled at any place and by any worker. So that's why interchangeability is the most important point. So this is a concept of interchangeability. There is some advantages of interchangeability. So first advantage is it is easy to manufacture in mass production. So when there is mass production, if the part is easily interchanged, then it definitely very helpful for mass production, getting mass production. Next, easy to replace the equipment or parts. After that, less cost of manufacturing, and easy for maintenance of job. So these are the few advantages of interchangeability. That's why interchangeability is most important in engineering sector. After that interchangeability, next point, that is limits. So what is limit? Limit of size can be defined that these are the two extreme permissible sizes for hole or shaft, and in between the actual size is available. So that is the definition of limit. So let's see limit. Okay, so here in this diagram there are two limits for hole and two limits for shaft. So maximum limit and minimum limit for hole, as well as maximum limit and minimum limit for shaft. So maximum limit is nothing but the higher value out of two limits, called as maximum permissible size of a job, called as maximum limit. And minimum limit is nothing but the smaller value out of two limits, called as called as called as minimum limit. So these are the two limits. After that, next concept, after that limit, next concept is fit. So fit is nothing but a degree of tightness or looseness, uh, called as between two matching parts, called as fit. So when there is assembly, so due to that, during that assembly, if the two matching parts are match with each other, so in between these two parts, if the two parts are tight or loose, so according to them, there are different fits are generated. So there are different types of fits. So first one is clearance fit, and second one is transition fit, and third one is interference fit. So these are the three types of fits. So let's see. First one is clearance fit. When during assembly of a shaft and hole, if the size of maximum limit of shaft is less than the minimum limit of hole, then it becomes clearance fit. That means there are some clearance is there, and hence that is called clearance fit. So example of clearance fit, it is tailstock, key and keyway, pen and cap, piston, cylinder. So these are the few examples of our clearance fit. So that means there should be some clearance between, there should be keep some clearance between matting parts. So that's why the assembly will get a smooth run. So this is the clearance fit. After that, next one is transition fit. So in transition fit, maximum limit of shaft is less than maximum limit of hole, but greater than minimum limit of hole. So if we see the diagram second, so here maximum limit of shaft is less than maximum limit of hole, but it is greater than minimum limit of hole. Then such type of fit are generally used for gears on shaft, for mounting gears on shaft, for mounting bearing on shaft, pipe on tap. So these are the uh, some examples of our transition fit. Next one is interference fit. So in interference fit, the minimum limit of shaft is greater than maximum limit of hole. So it's also called as force fit. If we see the diagram third, then the minimum limit of shaft is greater than maximum limit of hole. So its example is drill bit in drill jig, then impeller on shaft. So these are the three types of fits, and according to application, the types of fits are used.